1.4 angles and their measures. So just a quick review. We're going to start off the segment addition postulate. Postulate means it's an accepted statement. And in this case, the segment addition postulate was when we had a segment. We had A, B, C. This segment, AB, plus the segment BC. If I add these two parts together, I get the total segment AC. Now, angle addition postulate, what do you think that's going to be like? Well, that's the new one today, and you might guess we're going to be able to add two smaller angles, this angle plus this angle, to get the bigger angle. So let's talk about angles first. An angle is made up of two rays that have the same initial point. So here's one ray, here's the other. Those rays are the sides. Okay, so the sides of an angle are the rays, and the initial point is what we call the vertex. The exterior of the angle is on the outside, interior of the angle is on the inside. Now there's a couple different ways to name a angle. So let's get a angle here first. It's kind of a sloppy angle, but it'll work. So if I have angle ABC, so A, B, and C are all points that are on that angle, I can name it. The most common way is to call it angle ABC. So I have this angle marked, and then notice B, the vertex, that's where the two rays, the initial point of the two rays, the vertex has to be in the middle. Okay, the vertex has to be in the middle. Another way to name it, if there's only one angle here, it's pretty obvious what angle we're talking about. Actually, I'm going to hold on to that one. Notice that that's the same thing as angle CBA. B is still the vertex in the middle, but angle CBA is the same as ABC. Those are the same. Now, if there's only one angle here, I can also call it angle B and just use one letter if there's only one angle. Only one angle. Okay. Congruent angles have the same measure. Congruent angles have the same measure. Adjacent angles share a side. This is my definition of it. Share a side and vertex. But do not overlap. Do not overlap. That's kind of just a catch there. They share a side and vertex, but do not overlap. And you can see in this next picture, we have some adjacent angles. This angle, I'm drawing in green, would be adjacent to this angle that I'm going to draw in blue. Notice they share ray NP. NP is that side that they have in common. Now, if I erase this angle here, and I drew a straight angle is an angle that has a measure of 180 degrees. This angle and this green angle, they share a ray. They have the same vertex, but are they adjacent angles? And the answer would be no, because they overlap. This angle is on the inside of that angle. So that would not work. Alright, so let's name a few angles here. Name the angle in the figure. Could I say angle N? Does that work? Angle N. Some people might say, hey, I'm talking about this angle. Some other people might say I'm talking about this angle. What angle are we talking about? We got to be more specific than naming this angle by one point. We're going to have to use 3. Okay? So name the angles in the finger. There are angle M and P, angle O and P, those 2 angles, and remember I already showed you that third angle, that straight angle, angle M and O. Notice you could also flip the M and P, the P and the O, or the M and the O, right? The order you write the M and the O wouldn't matter, but the vertex N always has to be in the middle. The protractor postulate, another accepted, we accept it that you can use a protractor to measure angles. Is basically the idea of it. I do want you to note that pictures in homework and tests, especially like the tests that I make or quizzes that I would make, they're not going to be drawn to scale. You cannot just use a protractor to measure those pictures to find the angle. You'll have to do probably some algebra or look at theorems to figure out those angles. Okay, do not rely on the picture. Okay, the picture is just supposed to give you an idea. Okay, quickly to how to use a protractor. I think I have a protractor tool here. If I'm trying to find the measure of an angle, this part right here is kind of my bullseye. I can't even write on it, but this is kind of like the crosshairs of a gun. I want to find the vertex with this angle right there, and then I have to pay attention to these numbers on the side, 0, 10, 20, 30. That's the way I'm counting. That's how the angle's opening up. I don't want to start looking at 180, 170. That means it's getting smaller. So if I quick make myself an angle, if I want to find the angle measure of this angle, I'm going to take my protractor, find the vertex with my crosshairs, get that in sight, and then I have to line up this side right here with one of the sides of my angles. So I got to try to rotate my protractor until that lines up. It's pretty close here. Make sure my crosshairs are still on it. This line lines up with that, and now I can read up and I look and I got 2 numbers. Looks like, a little bit more than 60, so 61 or 62 degrees, or is it 118 degrees? Well, which numbers do I use? Remember, which way am I opening up? I want to start at 0 and I'm getting bigger. I'm not starting at 180 and getting smaller, right? Working up to, that's like a 62 degree angle. Angle addition postulate, you can add 2 angle measures together. So basically saying the measure of angle 1 plus the measure of angle 2 is going to equal angle, I'm going to draw this picture for you in a second, but let's call this angle A, B, C. This is angle 1 and angle 2. So I can add angle 1 and angle 2 to get the total angle. And we can use that to answer a question like this. So the backyard of a house is illuminated by a light fixture that has 2 bulbs. Each bulb illuminates an angle of 120 degrees. So here's bulb 1. It's a 120 degree angle. If the angle illuminated only by the right bulb is 35 degrees, so the right bulb is illuminating only 35 degrees. Here's the left bulb with That's 120. What is the total illuminated angle? Well, 35 plus 120, the total is going to be 155 degrees. Some things you should know: right, obtuse, straight, and acute angles. Okay, so right angle has a measure of 90 degrees, where a straight angle has a measure of 180. That's very important that you understand right and straight angles. You should be able to classify these. That a straight angle is 180 degrees. You're going to use that to set up a lot of equations. You'll use the right angle is 90 degrees to set up a lot of equations. Obtuse, is bigger than 90, and acute is less than 90. So it's important to be able to estimate angles, just to have a kind of a rough idea. And when I estimate an angle, I like to draw in like a 90-degree angle, compare it to a 90-degree angle. So I picture a 90-degree angle. Now that might not be that good, but it's an estimate, right? And then I look, okay, so that's a 90-degree angle. I bet a 45-degree angle, 90 divided by 2, would be about there. So I might say this is a 30-degree angle. If I was going to estimate this one, and once again, pick one of the sides and make a right angle off of it. So it's less than 90, but where's 45? Maybe about there. So I might guess that this is more than 45. I might say it's about 60 degrees. This angle down here is kind of pretty small. There's my right angle. Split it in half. That's a 45-degree angle. That looks like maybe 1, 2, 3/3 of 45. So I might say what? 15 degrees. That's my estimate. And which angle is bigger? This angle or that angle? Now, a lot of people will tell me that this angle is bigger just because the rays go out further. I think students have been getting wiser on me and they haven't been caught. But remember, a ray will keep on going, right? They'll keep on extending. I can move this angle over and you'll see if I can. Looks like I can't. But basically, this one's opening up faster than this one. Okay, so angle B is the bigger angle. Here's your homework assignment for 1.4. I hope that this section went well for you. Have a good night, and we'll be working on it tomorrow in class. So